Good morning, everyone. This is Milton Naranjo talking about microelectronics for A/B certifications in the telecommunications career at ESPOL. So, what's microelectronics? It relates to the study and manufacture or microfabrication of very small electronic design and components. Usually, but not always, this means micrometer scale or smaller. These devices are typically made from semiconductor materials. What are semiconductor materials? For example, first the use of this microelectronic design. For example, what you see at the picture is the back of a television, 4K TV. As you can see, there are many components, very small components that make the whole circuit. So what's the main actor of this microelectronic thing? It is called the MOS. What's MOS stands for? Well, as well as the junction field effect transistor, we all know the JFET. There is another type of field effect transistor available whose gate input is electrically insulated from the main current carrying channel and is therefore called the isolated gate field effect transistors. Most common type of FET, which is used in many different types of electronic circuits, is called the metal oxide semiconductor transistor, field effect transistor, or basically MOSFET, as we all know. The ultra thin isolated gate electrode can be thought of as the place of a capacitor. The isolation of the controlling gate makes the input resistance of the MOSFET extremely high, way up in the mega-ohms region, thereby making it almost infinite. As the gate terminal is electrically isolated from the main current carrying channel between the drain and source, no current flows into the gate. And just like the JFET, the MOSFET also acts like a voltage control resistor, where the current flowing through the main channel between the drain and the source is proportional to the input voltage. As you can see, we have the gate voltage below zero or in the negative region. The way it behaves, you have at the top of the layer you have the negative polarization, comparing to the B part of the figure that has positive polarizations in the gate, which made the voltage of that part of the transistor positive. That's how the MOSFET would be looking when it's called microelectronic circuits. What you can see is the silice oxide that's the main component of the MOSFET. Here again we can see what the relationships are in terms of equations of the gate voltage and the voltage in general of the layer in between. So what's behind the transistors? We have the first transistors, as you can see. What you can see in the picture is a replica of the first transistors that were made, built in the 1947. The transistor was successfully demonstrated on December 23rd, 1947 at Bell Laboratories in Murray Hill, New Jersey, by a group of scientists who were trying to make better electronics for their time to research faster. What is the main material of all microelectronic components? It is gold. The pH of the gold planet should be maintained very closely within 4.9, between plus and less 0.5, since the variation of this parameter have greater effect of the plating surface finish. It means that if we go below the thick measure, we wouldn't have the right conductance, but if we go upper or above the measure it says, we're gonna have too much resistance or the wrong conductivity, and also inappropriate currents will be flowing in the circuits, and we don't want that. There is a picture of an electronic circuit board using gold. As you can see, there are no components put in the board, but there are the holes or the ways or the roads the current will follow in order to connect one component to another. As you can see, there are many factories who develop and also manufacture by hand the boards we use in, for example, our laptop, our phone, or every single device which is small and have a variety of functions. They do it by hand. There are many parts of the process that are automated, but the most delicate are also supervised by a human. Thank you.